This lecture is the first of 2 lectures on significant figures. The second one will handle how you do math with them. This first one just has to do with identifying significant figures in a number. So in science, any type of science that we do measurement, our numbers are based on the measurements that we make. It might be how long something is, it might be the temperature, it might be the mass, but we're measuring a lot of things. Maybe it's the time. So what becomes important is that we only report or write down the numbers that are meaningful or the numbers that are significant. But then comes the problem of wondering, what does that mean? How do we know if a number is significant, or how do we know if a number is meaningful? So that's what we're kind of going to go through today. So I want you to think about a ruler. So any ruler that you normally use, it has different lines that measure different values. Now I want you to think about the lab that we just did with the 3 rulers that I provided. So there was the one that just had this whole thing as a meter. There's one that had the decimeter lines, and then there was the one that was a normal meter stick that had all the way down to millimeters. Now think about how easy it was to measure with one ruler versus another one to give me an accurate number. So that big long one that just said it was a meter, a lot of you are very uncomfortable with reporting any number because you were not certain, or the numbers that you had were not very meaningful. So that's kind of what we're dealing with here. So with that ruler that we had, or any ruler that you have, could we report a number like this? 22.4072643 centimeters. No. Any device that you have to measure length is not going to measure to this far. We would be lucky if we could get that something was 22.40 centimeters off of a ruler. Okay, so what we're going to be doing is seeing how many digits actually have meaning. How many can we be certain are really applicable to our measurement? So remember that we only record and we only report the numbers that are significant in a measurement. So there are going to be 3 rules that are going to be used to determine how many sig figs are in a number. You are going to see this term, and I'm going to use it. You'll end up using it. Sig figs is the same as significant figures. It's just making it a bit of a shorter term for us to use. So we're going to go over each of these rules, give you some examples, and it'll help us determine, once we get a measurement from someone, which of those numbers are significant. So the first rule is any non-zero digit is always significant. So hopefully this rule seems pretty obvious to you. If you measure something and whatever you're using to measure it, like a ruler, a thermometer, gives you a number, that number is significant. So let's say we had something that let's use a different thing here. 26.38. All of these digits are non-zero, which means that this number has 4 sig figs. Maybe we have something like 75.6. All of these are non-zero, so they are all significant. So we have 3 significant figures. So this is the easy rule. Then we start to get with things that are that are zeros, and that's when the rules kind of can get a little bit tricky. So the first one, any zeros between 2 significant digits are also significant. So let's say we are measuring something and we measure it to be this length right here. Now, when we're looking at this ruler that we have, we know that all the way down here represents 400. This represents 450. If we count out the scale on this, We're looking at 410, 420, 430, 440. So we know that this number is somewhere between 400 and 410. Okay, so what we have to do is we already assume that the tens place is a 0. So we could say or approximate that this was about 405. It's about halfway between the two. And just because this is a 0 doesn't mean that it's not significant. We just determined that the tens place in this number was a 0. So we have a non-zero, it's 4. A non-zero is 5. That 0 is trapped in the middle, which also makes it significant. So anytime you have a trapped 0 or a captured 0, anytime it's in between the two, it is also significant. So you might see a number like 6002. By default, this 2 is significant. By default, this 6 is also. And since both of these zeros are trapped in between there, they are significant as well. It doesn't matter if I have 1 0 between these two digits here and here, or if I have 50 zeros. Any zeros that are captured between two significant ones are also significant. All right, rule number 3. A final 0 or a trailing 0 that is only in the decimal portion are significant. All right. This rule seems to be the one that we get confused with a lot. It lends itself to examples are going to help with this. So if we have something like 0.00500, let's look at this number. We know that this 5 is significant. It's not a 0, it's significant. So now it says a final 0 or a trailing 0. So think about if someone is trailing in a basketball game or trailing in a football game. Trailing means they are behind. So a trailing 0 is going to be something that is behind a digit that's already significant. So a trailing 0 only in the decimal portion are significant. So these two numbers right here are trailing and they are in the decimal portion, therefore they are significant. This is the rule that you have to practice and practice and practice. So non-zero is significant. These are trailing behind, which means they are also significant. So that is also a final 0 as well. So maybe we have something, let's see, I'm going to erase this one. We have something like 0.03040. Significant, significant, because they're non-zero. This is a captured or a trapped 0, so it's also significant. And then this one is a trailing 0, therefore it is significant as well. So those are the 3 rules that are going to help you determine what is significant and what is not. But there are zeros that were not included in the rules. So you're probably looking back to this slide and thinking like, well, what about this one? What about this one? Are those significant? Are they not? We're going to go over those now. So zeros that are not included in the rules. The first are space holders on a number that is less than 1. So when you did scientific notation, a lot of those zeros were space holders. So if we had a number like 0.00500, we did that example already. These two zeros are what we call space holders, because in actuality we could rewrite this number as 5.00 times 10 to the negative third. Now, because they are space holders, when we write it in scientific notation, these numbers get dropped. We no longer see them. Therefore, they are not significant numbers. These numbers right here, since they were trailing zeros, are significant and will be included in this answer. So let me do another one here of that same example that we just did. So that was 0.03040. So we know significant, 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 trailing zero in a decimal, also significant. Let's rewrite this into scientific notation. 3.040 times 10 to the negative second. Now this zero right here, that's just a placeholder. That's just one that once we write it in scientific notation is no longer there. So those space holder zeros are not significant numbers. When you write it in scientific, if they disappear, they are not significant. So our next one, a zero to the left of a decimal on numbers less than 1. What does that mean? Some of you were asking when we're doing the metric conversions, a number, we'll just keep using the same example, why I was writing this number right here. Now, I said before, the reason I write this number right here is so it is obvious that this is a zero, or in that this is a decimal. The only reason we write that zero is to make it evident to those reading the number that that is a zero, not a period, or to make them realize it is actually there. So a zero to the left of the decimal, this is to the left, on a number less than 1, this is less than 1, this number is not significant. It is only there for conventional purposes. It's only there for us to recognize that this is a decimal. So that zero, also not a significant number. Now, trailing zeros in a whole number. So a whole number is something that does not have a decimal. So something like 200. Significant, it's not a zero. And now we're wondering, what about this number? What about this number, or this zero? These are trailing zeros. Trailing means behind in a whole number. Whole number is not a decimal. These are not significant numbers. Trailing zeros in a whole number are not significant. So maybe we have something like 25,000. Significant, significant, not. So this number would have one significant number, and this one would have 2. So now, numbers like this kind of depend on how the number is written. If this 200 was written like this, 200.0, then now we would have 1. This is a trailing 0 in the decimal, so that is also significant. These now become trapped, so now we have 4. So that is where it depends on how someone writes the number. If we just say that it is 200 centimeters long without the decimal, that means we think it's about 200. But if someone tells you that it's 200.0 centimeters long, that means it is exactly 200 centimeters. Therefore, we value or consider all of these numbers to be significant. All right, we also have exact numbers. So exact numbers would be things like the number of people in the room. So these are numbers that are based on counting how many of something is present, not on measurements that we make with an instrument such as a thermometer or a scale or a ruler. So something like those equivalent statements we talked about, that 1 inch equals 2.54 centimeters, there are exactly that many centimeters in 1 inch. So if a number is exact, it does not affect the accuracy nor how many significant numbers we're talking about. So numbers that are exact, all digits are significant. So when we're doing things like counting or equivalence statements, all numbers are significant. So now we're going to do some examples. So you might have to flip back and forth with the rules, but we will go over each of them. 3.0800. What I find the easiest thing to do is always look at how many digits are non-zero. Those are the easiest ones to get out of the way. Non-zero, non-zero. Now we're going to start looking at our zeros and see what rules they apply to or not. Now this first zero right here is trapped. It is between two non-zero digits, therefore it is significant. Now these two. This last zero is a trailing zero in a decimal. Remember, it is in the decimal portion. It's trailing. It is significant, which means that this zero right here is trapped, so it is also significant. I find the easiest way to do this, go one at a time when you're first doing it. Once you get the hang of this, you'll be able to look at a number right away and say, that has 6 digits, that has 2, that has 4. But when you start, go through what you know first and then knock them out each one at a time. So we have 1, 2, 3, 4, 5 sig figs. Now looking at this number. 1, 2, 3 are non-zero, so we know that to start with. Now let's look at this one. That is one of those numbers we said is not significant because it is a zero that is to the left of the decimal. That is just there simply to indicate to us that this is a number that's a decimal, so it is not. These two right here are simply placeholders because I could rewrite this as 4.18 times 10 to the negative third, because 1, 2, 3 spots. So these are simply placeholders because they get dropped when I write it here. So that leaves me with 1, 2, 3 sig figs. I want you to try these two on your own. Pause the video and come back, and then we will review them together. All right, now that you've tried them, looking at this number, anytime you see this at the end, it just means it's been written from standard form or decimal form into scientific notation, which means that those space holder zeros would be there if we were to write the number out completely. And we know that those space holders do not matter, so we don't really have to even think about this when we're counting our zeros. First, we go to our non-zero digits. Non-zero, non-zero. This guy is trapped, so this has 3 significant figures. This one, non-zero, non-zero, non-zero. We know those. Then we have this 0 and this 0. They are not in a decimal, and they are trailing in a whole number. So remember, trailing zeros in a whole number are not significant. So not significant, not significant. Trailing zeros in a decimal are significant, okay? So you have to be able to remember trailing zeros whole number, not significant. Trailing zeros in a decimal are. So we have, counting up, 1, 2, 3. This also has 3 significant figures. I want you to pause again, try these on your own, come back, and we will look over them. All right, hopefully you have these done. Let's take a look Non-zero, non-zero, non-zero. Those are all significant, easy ones. Now let's skip. We're going to skip this one and we're going to skip this one. We're going to move over to this 0 on the end. This is in the decimal place, or the decimal portion. It is trailing. It is at the end. Therefore, it is significant. Now, this guy and this guy are between a significant and a significant, which makes them significant and significant. They're trapped. They're captured in between. So we have 1, 2, 3, 4, 5, 6 significant figures. Now we go to this last one. Non-zero. Non-zero, they're significant. This 0 is trapped, therefore it is also significant. And now we're looking at this guy and this guy. Remember, a 0 to the left of the decimal in a number less than 1. This number is less than 1. This 0 is left of the decimal, therefore it is not significant. It is just there for convention, just there so we can see those digits, or we can see that this is a decimal. And then this guy right here is just a placeholder, because I could rewrite this as 1.01 times 10 to the negative first, or negative second, sorry. I can move that decimal over. That 0 disappears when I write it that way, therefore it is not significant. So going back and counting in this problem here, 1, 2, 3 significant numbers. The next video is on math. So when I multiply two numbers, when I add and subtract, when I divide, in order to be able to do those problems, you have to be familiar with counting them first. So focus first on how many significant digits are in a number. And then you can come back and watch the math video, because that one is only going to make sense if you understand this.